Hey everyone, and welcome to this explainer. Today we're diving into a really beautifully structured framework designed to do something that is, honestly, incredibly difficult. And that's actually grading artificial intelligence. If you've ever found yourself wondering how developers really know if their AI models are getting smarter or, if they're just getting better at faking it, well, you are absolutely in the right place. I am super excited to guide you through this today.
So let's just jump right in. It is basically the ultimate modern question. When a large language model, an LLM, spits out an answer, how do we systematically know if it's accurate, if it's helpful, or if it's just completely making things up? I mean, we can't exactly hand an AI a multiple-choice bubble sheet, right? Human language is messy, it's incredibly nuanced, and there are literally 100 different ways to say the exact same thing correctly. So how on earth do we score that?
Well, that brings us to this really fascinating open-source GitHub repository by a developer named Sai Kiran Ramayanam. What they've built here is a comprehensive, multi-layered grading rubric. The whole objective is to take two different LLM responses and compare them against a perfect verified reference answer. But the cool part is it doesn't just rely on one single method to grade them. It uses rule-based metrics, it brings in human judgment, and it even uses model-based evaluation. It's basically a complete 360-degree exam for an AI. Here is our game plan for today. 1. Evaluating the AI. 2. Rule-based scoring metrics. 3. Human and AI judges. 4. Beyond the final score. And 5. The technology stack.
All right, let's kick things off with part 1, evaluating the AI.
The framework itself operates on a highly logical premise. Step 1, you just take two different AI answers to the exact same prompt. Step 2, you hold both of those up against a known, verified correct reference answer. And step 3, you evaluate the differences. It's actually a brilliant illustration of the scientific method applied directly to machine learning. It's an A/B test, but instead of testing, say, the color of a button on a website, we are testing the complex reasoning and generative capabilities of advanced neural networks against an absolute gold standard.
Moving right along to part 2, rule-based scoring metrics. So the framework begins its grading process with something called ROUGE-L. Now, ROUGE actually stands for Recall-Oriented Understudy for Gisting Evaluation. Yeah, it's a bit of a mouthful, which is exactly why everyone just calls it ROUGE. The crucial takeaway here is that ROUGE-L is a strict mathematical way to check how much of the generated text overlaps sequentially with that perfect reference answer. It specifically hunts down the longest common subsequence. Basically, it wants to see if the AI can string together the exact same words in the exact same order as the reference. It's strict, it's heavily mathematical, and it honestly leaves zero room for interpretation.
Next up in this rule-based toolkit is Blue. What's really interesting to note here is that Blue is actually originally designed for machine translation. Think translating French to English. It relies heavily on exact word and phrase matches to calculate a baseline quality score. So, for example, if the reference answer says, "the cat sat on the mat," and your AI says the feline rested on the rug, Blue is going to give it a totally terrible score. Why? Because it doesn't understand synonyms. At all. It only understands precise one-to-one matches.
To round out these math grades, the repo uses something called BERT score. And this perfectly solves that feline versus cat problem I just mentioned. Instead of demanding exact word matches, BERT score computes similarity using pre-trained language models to check the underlying context and the actual meaning. It literally maps the words into a high-dimensional space just to see if the core ideas match up, even if the vocabulary is slightly different. It's a much smarter, more flexible way to do a rule-based check. But, of course, strict mathematical rules can really only take us so far when we're grading fluid, natural human language.
Which leads us perfectly into part 3, human and AI judges.
This framework brilliantly contrasts two completely different types of subjective grading. Over on one side, we have human preference. This is exactly what it sounds like. Real people reading the responses and deciding which one is actually more helpful, more natural, and more accurate. On the flip side, we have the LLM judge. This is where we bring in a separate, incredibly powerful AI model to analyze and grade the responses of the models we are testing. Think about that for a second. We are literally using one AI to grade the homework of another AI. It's wild, but it saves a massive amount of time and scales infinitely better than relying solely on human graders.
Okay, part 4, beyond the final score.
Getting a shiny top-level grade is great, sure, but it really doesn't tell us the whole story. Understanding exactly why an AI received a specific grade is where the real analytical value of this repository kicks in. Once the base evaluations and annotations are wrapped up, the framework dives into correlation analysis. It checks things like, hey, does the LLM judge actually agree with the human judge? But even more importantly than that, it conducts deep bias analysis and failure analysis.
And let me tell you, this is exactly why this framework matters so much to developers and honestly, to all of us who use these tools every day. Bias and failure analysis are absolutely critical steps. They act as the ultimate safety net. If a model scores incredibly high on exact word matches, but then the failure analysis reveals that it completely hallucinates when you ask it for medical advice, or if the bias analysis shows it leans heavily into unfair or skewed assumptions, developers absolutely need to know that before the model is deployed to the public. The score alone just isn't enough. We have to fundamentally understand the flaws.
Finally, let's look at part 5, the technology stack. So, what exactly is running down in the engine room to make all of this deep evaluation possible? Well, this breakdown gives us a look at the entire tech stack powering the framework. Starting on the left, we've got the foundational data and math tools: Python, Pandas, NumPy, and scikit-learn. These handle all the massive data sets. In the middle, you have the natural language processing, or NLP tools, doing the heavy lifting. That's your Rouge, Sacreblue, and the famous Transformers library. And then, over on the right, the infrastructure and AI power. Docker is there to keep the environment perfectly standardized, and Google Gemini is in the mix, which is very likely acting as that powerful LLM judge we talked about earlier.
Now, this is super interesting. If you take a look at the code-base breakdown for this GitHub repo, it is literally 99.6% Jupyter notebooks. The main takeaway for you here is that this project is heavily driven by interactive data exploration. It is not just some black box script that you execute once and walk away from. It's an interactive laboratory. A developer can run a cell, check out the BERT score, run the next cell, read the Gemini LLM judge's specific feedback, and visually explore the correlation analysis right there on their screen. It is custom-built for hands-on, deep-dive investigation.
Which brings us to a final, slightly provocative thought about the future of AI development that I want to leave you with today. As this framework clearly shows, we are increasingly relying on incredibly powerful models like Google Gemini to act as the LLM judge for other models. It's efficient and it's highly capable. But if we rely on an AI to evaluate other AI, who evaluates the evaluator? Are we eventually going to need like a third tier of AI just to double-check the judges? It is a fascinating puzzle, and frameworks exactly like this one are the very tools we are going to need to start solving it. Thank you so much for joining me on this explainer, and keep learning.